Well, hello. It must be autumn because I found myself back upstairs in my little spare bedroom tinkering about something. Motorcycling weather has passed. It's raining. There's nothing that needs doing outside. And this room is at a nice tolerable temperature that Liam likes. So, tinker away I have. Came across these the other day in the parts cupboard. Some old lateral channel MOSFETs, the original Renesas 2SJ1058 and 2SK1058. Now obsolete. You can buy ones on eBay, but they won't be genuine because they stopped making these, I think, like 2007. So anyway, many years ago, I can remember coming across on the internet a schematic for a single-ended Class A resistively loaded N-channel MOSFET amplifier. And seeing as I found these kicking around in the parts bin, these are old, really old, I thought I'd just knock something up and make my own version. So, simple enough power supply. There's a transformer bridge rectifier, about 100,000 microfarads capacitance, which is loads of capacitors in parallel. 0.33 ohm resistor, 5 farads of capacitance. These are 25 farad caps in series. This takes out some annoying high frequency buzz from the rectification, the harmonics created. Pardon me. So that's the power supply. The loading in the drain of the FET is I've got it shown here as 4 ohm. It's actually two 100 watt heat sinked 8 ohm resistors on this nice aluminium heatsink. Transistor of choice is a 2SK1058 lateral channel audio MOSFET. There's a potentiometer across the power supply, which is to set the bias at the gate, and then another capacitor to filter any ripple off of it, and then to isolate the gate AC from that capacitor. There's a 220,000 ohm resistor. Probably could have gone a bit lower, but it was just the first one I grabbed. Then a small 2.2 microfarad coupling capacitor on the input, and a loudspeaker is connected to the drain and 0V via a 4,700 microfarad DC blocking capacitor, which is here. And that's the speaker today. So, zero negative feedback. What does that even mean? Well, negative feedback, you can break it down into 2 points. Negative, as in it subtracts. Feedback, as in we take part of the output and feed it back to the input. Now, in most amplifiers, apart from like some audiophile or esoteric designs or very basic designs like this one, that's what you do. It's a very powerful distortion noise cancelling technique. It allows you to have much lower output impedance. Loudspeakers are designed to be driven off of constant voltage amplifiers. That doesn't mean there's a constant voltage coming out of it. It means that no matter what the load impedance is, if say the output was at 10 volts, if I took the load away or put any number of load on there, it would still be 10 volts. So it has a very low output impedance. The current changes through the load rather than the voltage across the load changing as the load impedance changes. And the opposition being something like a guitar amp, which is a high output impedance amplifier. Whereas if, say, the signal you was driving, it was putting 1 volt output, if you put a much higher impedance load on it, that could rise to 5-6 volts. If you shorted it out, it would just basically attempt to just put the few milliamps of current through it, amp whatever it worked out to be at that time. So yeah, that's high output impedance. Zero negative feedback amplifiers are quite high output impedance, so they don't have the best low frequency response, because speakers like low frequency, and they generally have a lot of distortion, a lot of harmonics. That's a complete other topic for another day, but basically normally by feeding a portion of the output to the input and subtracting it from the signal going in, it would basically more faithfully represent the signal going in but at a higher amplitude gain. But people will argue it's not just about measuring, it's about what it sounds like. So if I strike my phone up here, I know not the best audio source in the world, and hit the play button, So I think it would be fairer if I had two of them, because I'm only in mono, so that always diminishes the enjoyment of listening to audio, and it's coming from a single point source rather than two sources. Ooh. Whoa, I don't know what's just happened there. I don't even know why my phone is... I don't know, that's not Moonlight Sonata. So yeah, but it sounded okay. A little bit lacking in bottom end, maybe a little bit flat sounding. Could have wanted a treble boost. That's probably down to the high gate capacitance of the MOSFET. The phone probably not driving it overly well, but it sounded okay. However, this is at a very low level, and so of course, if we do some measurements, so the raw DC voltage coming in is 10.7 or so volts. We can measure that here, look, on that point. See, 11 now, we've got some, obviously it's thin wire, so we've got some resistance. It's about 10.8 volts across the 4 ohm resistor. We are 6.1, so about 4.6 volts or so across here, so like 1.1 amps. And of course, obviously, short circuit. Beauty of things like this, it doesn't matter if you short circuit, it doesn't really hurt anything. And we're 6 volts across the transistor, so about 7 watts dissipated in the transistor, and 5 or so watts being dissipated. So yeah, maybe 11 watts, 10.5 watts in total being dissipated into this heatsink, which is warm. This has been running for a few hours. It's not hot, it's warm. So yeah, it works, I guess. It's quiet enough. Would I build one? Would I go to the trouble of building a big power supply and putting one in a case? I don't know. I'd want to do some tests, because this is at a very low level. The more gain you start trying to push out of this transistor, or the more power even, the higher the voltage swing, the bigger the variation between gain in the lower and upper swings of the signal. Ever more distortion you're going to get. But it is a dead simple amplifier. If I was saying, if you was going to build like a workshop amplifier and you wanted it as simple as it could be, one transistor, couple of resistors, you'd spend more on resistors and power supply than you would semiconductors, and it does have enough gain that you could listen to it plenty loud enough just off of the output from a phone. Get the thermal camera on the job. Should we put it on a differently? That's on the orange filter. Let me filters next. Where is that one? It's really hard trying to get both cameras. So the resistors on the left look hotter than they are because they have a anodized coating on them, so the camera's picking them up as having a different emissivity to the heatsink, so things are a different temperature, but then going to be the same temperature. These ones are dissipating the power 46 degrees. The transistor is at, it's really hard to do looking through a phone onto, oh come on, focus. Where are you? Oh yeah, I want to focus on everything but the 48. Yeah, I'm not entirely sure what I just filmed there, because you know, trying to look at two screens there and what I'm looking at on the bench as well. But if I was going to make changes to the circuit, I would probably use a capacitance multiplier supply here rather than all this capacitance. You don't actually need anywhere near this much. This is just to try and get rid of some of the hum. You know, that would be more than enough capacitance for the amp, and then just a small transistor-based capacitance multiplier. Probably worthwhile regulating the voltage there so it doesn't drift in bias, but it'd be so minimal it wouldn't really matter anyway. Maybe put a low value resistor in the source just to linearize it a bit more. I'd up the voltage. I'd probably up it to like 20 volts, run it maybe 4 amps or so. What would that be? Now you'd need every amp across 4 ohm is 4 volts. 8, 12 volts across a 4 ohm, that would leave 8 across the FET. Yeah, maybe, depending on what speaker you got. If you had 8 ohm speakers, I'd probably bias it to... It's hard to find a bias point, because you think, well, if I bias it halfway, I'll get equal voltage swing. Well, you won't. The FET itself won't go down to 0 because it has an on resistance, and likewise, the higher you get it to saturation, the more non-linear it gets. And the same happens as your voltage swings positive. You need to draw more current through this resistor, and it gets to a point where if you've biased this at halfway, well, if this is a 4 ohm resistor, for every amp of current flowing through it, it needs 4 volts. So if you're trying to draw 2 amps through this loudspeaker here at 4 ohms, that's going to be 8 volts. And then you need another 8 here, which is 16 volts. So you just can't do it because you only had a 20 volt supply. If you biased it at 10 volts, well, by the time you get to 8 volts across this resistor, you've only got 2 volts across here. So, you know, you can't get money for nothing, as it were. Which is why you generally would use a current source or sink, depending on which way around you've got your transistor. But it's a simple enough amplifier, and it works, and it sounds okay. It doesn't sound horrible. Yeah, I'm more of a fan of negative feedback based amplifiers myself, and more complicated circuits. I was just playing about. Like I say, I can remember the circuit from years. Probably still on the internet if you search for it. I think a few people actually build it. So yeah, I have loads of the modern equivalents of these nowadays. I got something in the pipeline I need to build for someone soon. So that's why I've been digging around components, just seeing what I've got. Some product bought another pair of these from Rapid Electronics before these went obsolete, and there's one of them, and the other one must be one of this one or that one. And for whatever reason, I did say, I think I might have accidentally broke the legs off one. I think as I was scavenging it out, something I've been messing about with it, I broke a leg, and it got to a point it was just no good anymore. You couldn't solder onto it, so I chucked it away. But yeah, it's just a nostalgia trip. I think these were from the very first amplifier I ever built, which was Randy Sloane's basic MOSFET design in his book, High Power Audio Amplifier Construction Manual. And I got these, my mate had, I had no money, I wasn't working at the time, shit was going on without going into my life story. Sort of end of 2004, yeah, very little money, didn't even have any accounts with like any electronic supplies. Mate was working at an electronics shop, he ordered me, hand etched the design, you know, with the old, drawing it out with the old pen and etching it in ferric chloride on copper clad board. And yeah, I had 2 of them. That was my amplifier for a bit. Not in the case, just screwed to heat sinks, sat on the frigging floor in an old caravan I was sort of living in at the time. Yeah. And yeah, here they are, the exact same transistors. Anyway, if you've watched this long, thank you. And any questions, comments, leave them down below. And yeah, I hope to see you again.